Alrighty, so today we're going to be having a look at trigonometry. And so just as a quick reminder, trigonometry is the study of angles and right-angled triangles. So here's a right-angled triangle. And the first thing I'm going to do is mark an angle. Let's mark this angle as theta. Well, now we can talk about the relationship between this angle theta and the three sides of it. So there is the adjacent side, and it is adjacent to the angle because it's next to it. But this side is also adjacent. The difference is that it's also opposite the right angle, and it's the hypotenuse. And the hypotenuse is the longest side of the triangle. And the longest side of triangle is always going to be opposite the right angle. The last side is the opposite. It's not opposite the right angle. In fact, it's adjacent to the right angle. It's actually opposite the given angle. And so we have these three shapes, right? And what we've learned is that there is a relationship between them. If you have a really big angle or a really small angle, that changes the lengths of the adjacent, the opposite, and the hypotenuse. Different angles will give you different shapes. SOHCAHTOA is just a way of memorizing the three relationships really quickly. The first one is the relationship between the opposite and the hypotenuse. The second one, cos, is to do with the adjacent and the hypotenuse. And tan is to do with the opposite and the adjacent. And in particular, the way we can write out all of these rules is that since it's S, it's sine of theta equals opposite over hypotenuse. For cos, it's cos of theta is equal to AH, so A over H. And for tan, T, tan theta equals O over A. Okay, and these are the three rules that we're going to be playing with. But because they're all the same, in a sense, we're going to be all right. So today we're just going to be looking at how to find sides. So let's look at a couple. Alrighty, so let's have a look at this one. And in this case, we know this angle up here is 20 degrees, and we would like to find both x, this side down the bottom, and y, this side on the angle, on a slant. Alrighty. So let's have a think about how we can do it. First thing I like to do is label all my sides in relation to the opposite, adjacent, and hypotenuse. So you can see here, y is the longest side, so that is our hypotenuse. X is opposite the angle, so it is O, and 10 centimeters is the adjacent, as it is next to the angle. It's touching the angle. Alrighty, so let's think about which relationships we'd like. Well, with O and A, we could use tan, and that would help us find x. With A and H, we could use cos to find y. But with O and H, we couldn't do anything because we don't know x and we don't know y, so we wouldn't be able to solve for either. So you always want to choose one where you know one piece of information and you're only missing one piece of information. So let's find O first. So, O and A is tan. So tan of theta, SOHCAHTOA, so O over A, and we just sub in what we know. Tan of 20 degrees is equal to opposite x over 10. So in this case, the variable is on the numerator, and all we need to do is rearrange it. X is currently being divided by 10, so we're going to times both sides by 10. Which gives us tan 20 degrees equals x. Alrighty, well we've actually worked out x, we just need our calculator. And we find out that it is 3.64, and in this case, centimeters. And I'm rounding here. It was actually 639, but I'm rounding it up to 64. Alrighty, so that's how we found x, and we now know what the length of x is. Now we want to find the length of y. So let's use a different relationship. Let's use the adjacent and the hypotenuse. So that's going to be cos. So cos theta equals the adjacent over the hypotenuse. So there's a h there. Right, so now we're just going to substitute in. The angle theta is 20 degrees. The adjacent is 10. And the hypotenuse is y. And this one's a little bit different. In the other one, the variable was on the top. But here you see the variable is on the bottom. And so we have to use different strategies depending on where the variable ends up, whether it's in the top or the bottom. Alrighty, so let's get y to the other side. And there's a reason we're doing this, is because we don't really want y on the bottom. So we're going to times both sides by y. So now we've got y times cos of 20 and equals 10. Well, now we're timesing y by cos of 20, so let's divide both sides by cos of 20. And this gives us y on the left-hand side and 10 over cos of 20. Alrighty. Now, just put that into your calculator. Equals 10.64 centimeters. And that's rounded down, 641. Alrighty, so that is how you can use SOHCAHTOA to actually solve for the sides in a triangle. Just be careful that you recognize when the variable's on the top or when the variable's on the bottom. Alrighty, I'll see you in the next one. Goodbye.